Hello, this is Balaji. Today's topic is magnetic particle testing. Now I am going to present the almost topics in magnetic particle testing. Introduction of NDT and MPT. What is NDT? NDT is a non-destructive testing and MPT is magnetic particle testing. Is also referred as magnetic particle inspection is a non-destructive testing method. Magnetic particle inspection is a non-destructive testing method that can detect surface and subsurface flaws in ferromagnetic materials. History of magnetic particle testing. The ancient Greeks were the first to discover this phenomenon in a mineral they named magnetism. Platon and Bridgman, Becquerel, and Faraday discovered that all the matter, including liquids and gases, were affected by magnetism, but only a few responded to noticeable extent. The earliest known use of magnetism to inspect an object took place as early as 1868. Introduction to magnetism. A magnetic pole is a point where the magnetic line of force exits or enters a material. Objects that possess the property of magnetism are said to be magnetic or magnetized, and the magnetic lines of force can be found in around the objects. Magnetic lines of force around a bar magnet. Opposite poles are attracted, similar poles are repelled. Magnetism is the ability of matter to attract other matter to itself. Basic principle of magnetic particle inspection. Magnetic particle testing has a relatively simple concept. It can be considered as a combination of two non-destructive testing methods, magnetic flux leakage and visual testing. Magnetic properties. Source of magnetism, magnetic poles, magnetic field, magnetic flux lines, electromagnetic field. First of all, what is magnetic field? Magnetic field is the region around a magnetic material or a moving electric charge within which the force of magnetism acts. Magnetic field lines. Magnetic field lines are imaginary lines. Magnetic field lines are a visual tool used to represent magnetic fields. They describe the direction of magnetic force on a north monopole at any given position. What is magnetic flux? Magnetic flux is defined as the number of magnetic field lines passing through a given closed surface. It provides the measurement of total magnetic field that passes through a given surface area with respect to the direction of the magnetic field. There are three types of magnetic materials: diamagnetic materials, paramagnetic materials, ferromagnetic materials. What is diamagnetic material? When placed in magnetic field, the lines of force tend to avoid the substance. Diamagnetic materials are slightly repelled by a magnetic field, and the material does not retain the magnetic properties when the external field is removed. Example for diamagnetic materials: copper, silver, gold. This material cannot be tested by magnetic particle testing. Paramagnetic materials. The lines of force prefer to pass through the substance rather than air. Paramagnetic materials, though the material are weakly attracted by external magnetic field. Example for paramagnetic material: magnesium, aluminum, lithium, etc. This material cannot be tested by magnetic particle testing. Ferromagnetic materials. The lines of force tend to ground into the specimen. This material conduct magnetic current and also strongly attracted by the magnetic force. Example for ferromagnetic materials: iron, nickel, cobalt. This material can be tested by magnetic particle testing. What is magnetized material and demagnetized material? Magnetized material. Position of domains in magnetized material are in arranged manner. Demagnetized material. Position of domains in demagnetized material are in unarranged manner. Basic physics of magnetism. Permeability. Permeability is a measure of how easily magnetic lines of force can pass through a material. Redundancy. Property of magnetic material in retain magnetism even with the absence of magnetizing field is known as redundancy. Basic physics of magnetism. Polarity refers to orientation north and south pole space. Susceptibility. Material to the external magnetizing force is defined as magnetic susceptibility. It is a dimensionless proportionality constant and it is material property. Residual magnetism. It is the amount of magnetism that the magnetic material retains after a magnetizing force is removed. Porosity. Magnetizing field is needed to demagnetize the magnetic material completely is known as porosity. Hysteresis loop. A graph of magnetizing force versus magnetic flux density referred as BH. Hysteresis loop shows the history-dependent nature magnetization of a ferromagnetic material. Once the material has been driven to saturation point, the magnetizing field can be dropped to zero, and the material will retain the most of its magnetism. It removes its history. A great deal information can be learned about the magnetic properties of material by studying a hysteresis loop. Hysteresis loop, also called as hysteresis curve, it is a four-quadrant graph that shows the relation between the induced magnetic flux density and a magnetizing force. The driven magnetic field must be reversed and increased to a large value to drive the magnetization zero again. It is a magnetic memory device. When driving a magnetic field drops to zero, ferromagnetic material retains a considerable degree of magnetization. Is useful as magnetic memory device. Material magnetized to saturation by alignment of domains. The material follows a non-linear magnetization curve when the magnetized from a zero field value. Types of magnet. Permanent magnet, electromagnet. Permanent magnet are materials where the magnetic field is generated by internal structure of the material itself, but certain materials are called ferromagnets. Electromagnet. A current through the wire creates a magnetic field which is concentrated in hole denoting the center of the coil. An electromagnet is a type of magnet which the magnetic field is produced by electric current. Types of current. Alternating current is used to demagnetize the material. Direct current it is used to magnetize the material. Half-wave direct current, full-wave direct current, three-phased full-wave direct current. Alternating current is a electric current which periodically reverses direction and changes itself magnitude continuously with the time in concentrate to direct current which flows only in one direction. Alternating current reverses in direction rate of 50 or 60 cycles per second. Direct current is the one directional flow electric charge. Frequency of direct current is zero because the flow of current is one direction. Example for direct current: solar cells, generators, rectifiers, batteries. Half-wave, full-wave, three-phase full-wave DC current. Full-wave rectified alternating current. When single-phase alternating current is passed through a rectifier is allowed to flow in one direction. Full-wave rectified alternating current. Full-way rectification inverts the negative current to positive current rather than block it out. Three-phase full-way current, often used to power industrial equipment because it has more favorable power transmission and line loading characteristics. What is solenoid coil? When a current is passing through a solenoid coil, a magnetic field is created along the axis of the solenoid. Solenoid is a coil of wire, but when you run a current through it, it becomes an electromagnet. Methods of magnetization: direct induction prods, direct induction head short, indirect induction central conductor, indirect induction yoke, indirect induction coil, direct induction prods. Single and double prod contact discontinuities are defined by the magnetic field generated between the prods. Using the method, we can find all the type of cracks like longitudinal and transverse crack. Prods contacts are often used in a magnetic particle inspection of large castings and weldings. Advantages: easy portability makes them convenient to use for field inspection of large tanks and welded structures. Such a local contacts do not allow produce true circular fields. Direct induction headshot. A circular magnetization of workpieces that are clamped between the contact head. Direct contact headshot method. Similar unit can be used to supply the magnetizing current to the central conductor. This is done by clamping the parts between the contact headshot, generally on a bench unit. It can give you an immediate indication defects and discontinuities. The coil and the unit can be used for longitudinal magnetization. Small parts have no openings through interior circular magnetic fields are produced by direct contact to the parts. Indirect induction central conductor. Use of central conductor, circular magnetization of long hollow cylindrical parts and short hollow cylindrical or ring-like parts for the direction of discontinuities on inside and outside surfaces. Central conductors are made up of solid and tubular non-magnetic and ferromagnetic materials that are good conductors of electricity. Basic rules regarding magnetic field around a circular conductor. Magnetic field outside a conductor uniform cross section is uniform along the length of the conductor. Magnetic field is 90° to pass of current through the conductor. The flux density outside the conductor varies inversely with radial distance from the center of the conductor. Indirect induction yoke. There are two basic types of yokes. They are used for magnetizing purpose. They are permanent yoke, electromagnetic yoke. What is permanent yokes? Yokes are used for application where a source of electric power is not available or where arc is not permissible as in a explosive atmosphere. Electromagnetic yokes. Flux density of a magnetic field produced by direct current type can be changed by varying the amount of current in the coil. Yokes that use alternating current for the magnetization and demagnetization. It is have numerous applications. A design of an electromagnetic yoke can be based on the use of direct current, alternating current, or both. Indirect induction coil. Single loop and multi-loop coils conductors are used for longitudinal magnetization of components. Magnetizing force such as coil can be varied by changing either the current or the number of turns in the coil. The field in the coil has a definite direction corresponding to the direction of the lines of force running through it. Coil method. Portable magnetizing coils are available that can be plugged into an electrical. Transverse cracks, spindles, and shafts are easily detected with such coils. Types of magnetic particles. There are two types: wet magnetic particles and dry magnetic particles. Wet magnetic particles. Wet magnetic particles are typically supplied as a visual or fluorescent. Visual particles are viewed under a normal white light, and fluorescent particles are viewed under black light in closed room. Dry magnetic particles. Dry magnetic particle comes in a variety of colors. A color that produces high level contrast against the background should be used. Steps for magnetic particle testing. Pre-cleaning that specimen. Inducing a magnetic field in the specimen. Apply a magnetic particle to the specimen surface. Examine the component surface for defects. Repeat the test by changing the magnetic field. And last, demagnetization and post-cleaning the specimen. Reason for demagnetization. If ferrous parts are used in strong magnetic fields before they are tested, they should be demagnetized to ensure any field the part will need interfere with test. While demagnetization usually associated with the final operation of magnetic particle test, it can also occur a preparation stop. When a part is remagnetized in different direction, demagnetization may be recovered. There are three types of demagnetization method: heat treating method, alternating current method, electromagnetic method. Heat treating demagnetization. When a ferrous metal is heated to cure point, it transformed from a ferromagnetic to paramagnetic. When the part cools below the cure point, the material returns to ferromagnetic unmagnetized condition. Alternating current demagnetization. Most of common method of demagnetization with the alternating current is pass the magnetized part through a coil energized with the alternating current. Electromagnetic demagnetization. There are several techniques for demagnetizing an object using electromagnetic energy. All of these techniques subject as magnetized object to be magnetic force that is continually reversing its direction and gradually decrease its intensity. Advantages of magnetic particle testing. Find the flaws on the surface and near surface. Fast examination method with the immediate result. An easy method as compared to other NDT. Defects are visual and visible directly on the surface. Relatively safe method. Hard test can be performed using dry particles. Less training requirements and relatively safe. The shape and size of cracks are indicated. It is portable, small portable equipment and materials available in spray cans. It is low cost material and associated equipments are relatively inexpensive. Disadvantage of magnetic particle testing. Only surface and near surface defects can be detected, only applicable to ferromagnetic materials. Test in two perpendicular directions recovered. Only materials with relatively non-porous surface can be inspected. Inspector must have direct access to surface being inspected.
So the first process in magnetic particle testing is pre-cleaning the test material. Pre-cleaning is done to remove the dust particles or any other impurities which may show false indications. Here the cleaner is used for the pre-cleaning process. The test material is cleaned by using the cleaner. The device which I am holding in my hand is called yoke. Yoke is used for the magnetization of test material. Before the testing process, the yoke device should be calibrated. Here the calibration is done by lifting the test material. After calibration, we have to do the testing process. In this method, the yoke axis is of 45-degree angle with respect to the longitudinal axis of the material. After magnetizing the test material, magnetic particles are sprayed from the blower. Then the magnetic particles are removed from the blower by blowing the air from the blower. Now magnetic particles will be attracted by the defects in the crack due to the magnetic flux leakage. Then the same process has to be repeated till the corner of the testing material. So finally, the defects can be identified by the magnetic particles which are attracted by the magnetic flux leakage in the cracks. Then the position and size of the defects has to be measured. Here the measurement of the defects is done by using the ruler. So after the detection of flaws, the test material has to be demagnetized by passing the alternating current from the yoke. Then we have to check whether the test material is completely demagnetized. It is done by using a gauge meter. This is called gauge meter. When the gauge meter shows zero deflection, we can confirm that the test material is completely demagnetized. Final process is post cleaning. It is also done by using the cleaner.
Thank you for watching.